Bismillahirrahmanirrahim. In today's lecture, I am solving problem 3-29E from the book Thermodynamics in Engineering Approach by CENGEL 9th edition. So, the statement of the problem is 1 pound mass of water fills a container whose volume is 2 cubic feet. The pressure in the container is 100 psia. Calculate the total internal energy and enthalpy in the container. So, in given data, mass is given to us 1 pound mass of water. It means that mass of water is 1 pound. M means per mass. Fill a container whose volume is total volume is given to us 2 cubic feet. The pressure in the container is 100 psi. So pressure is given to us is 100 psia. Required is to find the total internal energy. Number first, find total internal energy and total enthalpy. U is total internal energy, capital U, and capital H is total enthalpy. So first I check whether our properties are in subcooled region or in wet region or in superheated region. This is TV diagram, temperature, and this is specific volume and pound mass and cubic feet per pound mass and temperature is in degree Fahrenheit in this case. So first, and this is saturation curve. This is saturation. This region is subcooled region or compressed liquid region, or this region is wet region and this region is a superheated region. This is wet region, mixture of liquid plus water, mixture of liquid plus vapor. This is superheated region. So first I find the region of the working fluid. So pressure is given to us and total volume. For total volume, first we find specific volume. Specific volume and total volume will be same because mass is 1 pound mass. As we know that specific volume is equal to total volume divided by mass. Total volume is 2 feet cube and mass is 1 pound mass. So specific volume is 2 cubic feet per pound mass. Now from saturated steam table, at pressure is equal to 100 psia. Vf, find Vf. Vf is equal to 0.017736. 0.017736 cubic feet per pound mass, and Vg is equal to 4.4324 cubic feet per pound mass, and the specific volume given us is 2 cubic feet per pound mass. 2 is between these values Vf and Vg, and we don't know that this line is saturated liquid line and this line is saturated vapor line. At this line the volume is Vf, volume of liquid, and on this line the volume is Vg, volume of fluid, volume of gas or dry saturated vapor. And here volume is 0.0177, here volume is 4, and the volume given to us is 2, means between these two values. It means that the volume given to us is between this point and this point here, and the wet region, mixture of liquid plus vapor. As we know that, as we know that volume given to us is V, which is equal to 2 cubic feet per pound mass, is greater than Vf and less than Vg, between Vf and Vg. So the properties of water is in wet region are in the mixture of liquid plus vapor, mean wet region. So we will use saturated steam table, not superheated. So we will use saturated steam table. So first we find x. First we find x to find h. For finding h, first we find dryness fraction, because dryness fraction is important in this region. On this line dryness fraction is 0, and on this line dryness fraction is maximum 1, and in this region dryness fraction is between 0 and 1. So first we find dryness fraction. Dryness fraction is denoted by x. First we find dryness fraction. So for that we use the formula of specific volume, as specific volume is equal to Vf, volume of liquid, plus x, dryness fraction, volume of dry saturated vapor, minus Vf. Rearrange this equation, so x is equal to V minus Vf divided by Vg minus Vf. So putting values for x, V is given to us 2 minus Vf from table 0.017736 unit is feet cube per pound mass, divided by Vg is equal to 4.4324 minus 0.017736 feet cube per pound mass. Now x is equal to, this will be cancelled with this, and now this is simple calculation. So find x, and x will be equal to 0.449. Now we are finding h, and h is equal to hf plus x, hg minus hf. So first we find hf and hg. So from for h, for enthalpy, from saturated steam table, at pressure is given to us as 100 psia. HF is equal to 298.57 BTU per pound mass, and Hg is equal to 1187.5 BTU per pound mass. So H is equal to HF plus X Hg minus HF. So H is equal to, putting values, HF is 298.57 BTU per pound mass, plus X is equal to 0.449, Hg is equal to 1187.5 minus 298.57, just putting value BTU per pound mass. So simply calculate this value, unit is BTU per pound mass, and specific enthalpy will be equal to 698 BTU per pound mass. If we have to find total enthalpy, we know that specific enthalpy is equal to total enthalpy divided by mass. So this implies that total enthalpy is equal to mass multiplied by specific enthalpy. So mass is given to us as 1 pound mass, and specific enthalpy is 698 BTU per pound mass. So pound mass will be cancelled with pound mass. So as mass is 1 pound mass, so specific enthalpy and total enthalpy are equal. BTU. Now we have to find internal energy. So if UF and UG are given in the steam table, then you can use table for finding U. But if not available, then you will use formula for U. For U, you will use formula U is equal to H minus PV. H specific enthalpy is given to us, is already found by us 698 BTU per pound mass. First we have to find PV in this unit and BTU per pound mass. First we have to find PV term and BTU per pound mass. So if we directly put the values in PV, the unit will not be BTU per pound mass. Therefore, first priority to find this in BTU. So formula for PV is in BTU per pound mass is pressure, food pressure, and psia. This P. Now to convert this pressure into, this is in pound per inch square inch, but we need this in pound per square feet. So convert this value. This psi is basically pound mass per square inch, but we need this in square feet. So to convert this in square feet, multiply by 144, and this will be converted into inch square per square feet. So inch square will be converted into square feet. This inch square will be cancelled, and this will be pound mass per square feet. Now this after multiplying by 144, and volume is in feet cube per pound mass, but there is no term BTU involved, and we need, so to convert this into BTU per pound mass, divide by 778.169 feet, multiply by pound mass, divided by BTU. So this feet and this square feet will be cancelled with this cubic feet, and this pound mass will be cancelled with this pound mass. Now simply multiply this. Pressure is in 100 psi, pressure is P is 100 psia. These values are already cancelled. This is 144. This is specific volume is given to us as 2 cubic feet per pound mass. These units are already cancelled. Divide by 778.169, and in denominator pound mass per BTU is equal to BTU per pound mass. So PV term is equal to, simplify this value, so this will be equal to 37 BTU per pound mass. Now we can easily find specific internal energy. Specific internal energy is H minus PV. H is equal to 698 BTU per pound mass, and PV is equal to 37 BTU per pound mass. So specific internal energy is equal to 661 BTU per pound mass. But we have to find total internal energy, as specific internal energy is equal to total internal energy divided by mass. So total internal energy is equal to mass multiplied by specific internal energy. So U is equal to M is 1 pound mass already given to us, and specific internal energy is 661 BTU per pound mass. So this pound mass will be cancelled, with pound mass. So this will be equal to 661 BTU. So we find total enthalpy, which is 698 BTU, and total internal energy, which is a 661 BTU, and problem is completed. So for more videos, please like and subscribe my YouTube channel and share with your friends. Thank you.